So today, I wanted to go through and start fitting the code that I wrote yesterday for the Halloween project into a state machine so that we can reduce some of the splocking code. I moved outside to try and reduce some of the background noise, or at least the annoying background noise. But the downside about that is that we lose my NDI camera. Like the camera quality is here is probably not going to be sharp, but we reduce some of the lag, so that's great. Let's see. So basically, what I did in the yesterday and in the last videos, I went through and fit together all the main pieces of the Halloween this Halloween project. So the idea is that whenever someone walks up to the treasure chest, once they get past a certain distance, like close to the treasure chest, it will start opening up, and then and like kind of open and close based on how close they are. And then fire a little color pattern in the background. And then maybe if I extend it, it'll have sound effects and stuff like that. But the basic is just like a open and close based on distance. So yesterday I went through and fit in the LEDs for the light pattern, the servo to open and close the lid, which is obviously in place, and then the ultrasonic sensor to go through and detect the distance away from the treasure chest, which is eventually going to get fit into some part of this. And the problem, even though all of that is in there and is working, is that we're running into blocking code. So if we look at the code down in the loop, we have the light pattern firing. We have the ultrasonic sensor doing its measurements and then calculating the distance, and then we have the servo motor lifting and closing the lid. But because all of this is written using delays, we're actually stopping the microcontroller multiple times before it can move forward. And specifically with the servos, this delay is slowing everything down. Like the light patterns on the inside should be moving really fast. Actually, let me comment this out and upload it so that we can see the difference. So right now the LED strip is moving very slow. Like, I mean, it's moving one frame at a time. But once the code is done uploading, let's see. Let's see. Come on. Oh, I think I switched ports. Okay. So now, if we comment out the servo loop and we upload it, once the new code is up, let's see, there we go. We'll see that the light pattern moves considerably faster. I mean, this is roughly the animation speed that we should have been expecting for it. So, but it can't move at this speed because this like the light pattern is moving in frames conceptually, and we can't advance the frames at this speed if we're also waiting for the servos to open and close. So the way that we can get around this is by writing a state machine. So in a state machine in the world of microcontrollers and in the world of Arduino is a way of being able to set specific intervals for things to be checked and triggered. And So you can think of it kind of as you think of it as like kicking a can down the road, where the kick is the action that you're doing, and the distance traveled is the interval. So you kick the can, and then you walk a little bit, and you're not kicking while you walk, but then as soon as you get to the can again, you kick it. So if you can kick a can exactly like 5 seconds of distance, that's not the best analogy. So, but it's basically it's firing things at a specific interval, and I think that I can, yeah, I should be able to, yeah, I'll do an example that will hopefully make all this make sense. So let me comment out all the code from yesterday. Okay, and then there are a couple of things that we need to do for a state machine. We need to track an interval for an action that we're going to perform. So let's see, which one should we start first? let's do the let's do the servo first, because it will be the most obvious thing. Let's see. We'll do the servo action every 100 or 1,000 milliseconds, so every second, and then like we'll just like open and close the lid without running the blocking code, and then we'll add in the light pattern so that you can see those two things running together. I feel like that'll probably be the most obvious. So first thing we need to do is grab now, what now is. So so there's a function called millis, and if we look at the definition, it returns the number of milliseconds since the Arduino began. So it's basically like this really long number. We're storing it in unsigned long. Actually, I think I have that backwards. Oof. I swear I can type. So we grab the current number of milliseconds that have passed since starting the microcontroller, and then to check to see if we've reached an interval that we want something to happen in, we do conditional. So if now minus the last time we checked, so we actually need to track the if the current number of milliseconds now minus the number of milliseconds from the last time we checked is greater than the interval that we want to check at, so servo interval, then we want to do some stuff, and then actually before I write out what we're going to do, if this conditional is true, it means that we're in the enough time has passed that we want to actually do something, but to be able to track the next interval, we have to update the last time it checked, which is now. So servo last checked equals now. So now we're set up, and now we can do something. So what do we want to do? Well, let's do the same. Let's do the same. Basically the same loop. We're just going to deconstruct it a little bit. So I'm gonna rough this in, then we can rename things a little bit better. So let's see. Servo. Actually. Right. So we'll do this. We'll say lid right eye, which is going to increase the angle at which the lid is raised. And actually, yesterday we found out that we need to use the starting angle. So and then the starting angle right now is just it's further up in the sketch, but is just 30, and our ending angle is 120. Okay, so we'll start at the starting angle, and we'll write that out, and then we'll increase it by 1 degree. And then this is the main part of the open loop that we've been doing, but now we need to add in the conditionals to tell it when to switch to the closing loop. So let's see. Actually, hold on. If I is greater than the ending angle, if I is greater than the ending angle, then we want to. Let's see. Nope. We can't do it with just a inequality check, because then as soon as we flip it, we're basically gonna end up stuck at an end. So we also need to store the the direction. Okay, we also need to track the state of the direction. And this is actually the state part of the state machine. I guess I should explain. The state machine is built to two concepts. There's the state, which is the stuff that you're trying to track as you move forward in these changes. And then there's the machine, which is the mechanism for actually tracking the interval and doing the advancement. So we're building up our state and then fitting it into our machine. So it's not actually, if it's greater than the angle, it is if open lid. So if that's true, then we're going to increment and else we're going to decrement, and then we also need to determine when we should flip it. So we'll increment, and then if I is greater than, at this point, if I is greater than or equal to ending angle, then we're going to switch open lid. Going to flip that to false, and then we're basically going to do the same thing. I is less than or equal to open. Oh, what did I call it? Ending angle and starting angle. Then we're gonna flip it to true. Okay, so restating before we do the upload and before we do the verify to make sure that I didn't goof anything up. The way the state machine works, we grab the number of milliseconds that have passed since the Arduino has started, which means we're going to start counting 0, 1, 2, 3, 4, 5, 6, 7. And each time we go through the loop, we're going to subtract that from the last time the interval checked, which starts at 0. So 0 minus 0, 0. 1 minus 0 is 1, etc. So during the first interval, everything is going, both the now and the difference between that and 0 is going to step in the go in step with each other, and each time we do that, we're going to compare that to the interval. So we will be counting up until we hit 1001. So as soon as we hit 1001, we'll compare 1001 minus the servo last interval check, which is 0, and that will equal 1001, which is greater than our interval. And at that point, then we do our thing. So we go through, we set the servo to the angle that we want to open it at. We do the conditional check to see if we need to increment or decrement from there. We handled that. We flip the state of the open lid state if we need to, if we've surpassed our angle or not. And then at the very end, we take that 1001 and we put it into the servo last interval check. And now we keep going. The next time we get now, it'll be 1002. And now it'll be 1002 minus 1001. Is that greater than 1000? Of course not. It's not. So the entire thing will start stacking up until we hit the next the interval, and we will subtract 2000. Let's see, should that, or maybe this should be greater than or equal to, so that whenever we hit 2001, yeah, let's do greater than or equal to, so whenever we hit 2001, we will subtract that from 1001. That will be 1000, and then it will be greater than or equal to our interval, and then we'll fire this all again. Oh god. Okay, let's upload this and see it work theoretically. What did you not like? Didn't like that. Why didn't you like that? Unterminated comments. Oh, that's weird. Okay, it's got upload. So now every second we should get. You know what I should have done, which I'm gonna do now. Oh my goodness. Let's print out I so we can see it. We should see that value hopping up and down. So why are we not seeing it? Okay. Oh, we are seeing it. It's just going at it's going a degree a second. Okay. So let's lower the interval. That was maybe a little bit dramatic. So it's probably really hard to see. But yeah, the servo is very slowly opening. Yeah, there we go. Very slowly opening the lid. We'll just wait until it does the flip and starts coming down. Oh, 1 degree a second was way too slow. Yeah, 120. Okay, so we're not too far away. Okay. Come on. Now we should see the flip. They're coming down. Okay, so you get the idea. So we're opening and closing. I will shorten the interval to 100 so that we can see it going a little bit faster. So we do all this, and like the obvious thing to say is like, oh great, we're opening and closing even slower than we did before. What's the point of doing it? The point of doing all this is that, yeah, we have speed control now. We can change the interval to control the speed at which we're going to open the servo lid, and it has no blocking code. We have no delays in here to actuate this the servo, and we could do this a little bit more efficiently. We could I'll probably go through and clean up the code so that we don't have as many nested conditionals. There are things that we could do to like kind of kick this around. And decide what we're going to do. But for now, we're going to run with it. And really, this project isn't going to be so complicated that it needs heavy optimization. So now, the reason why this is advantageous is now we can also, just to drive the point home, is we can enable our fire pattern. And because we are not writing blocking code for the servo actuating, we should see the servo opening and closing at a faster rate this time, and then the fire pattern going through at the speed that we're wanting it to go through. Nope, why are we not? There we go. Okay, and there we go. So yeah, it's a little bit better speed. I mean, like, I think that we're gonna get a little bit of jitter. Interesting. So, but as you can see now, instead of like waiting for the servo to go up and down, the light pattern is able to run unimpeded. Let's see. So I think as far as like removing that jitter, I mean, ultimately it's not going to be like going up and down on its own. We're going to tie that into the ultrasonic sensor. But I think that if we just found like the right interval, this would get a little bit less choppy. So let's try uploading it at interval of 50. So now we have this. Now that we have this in place, we have this one spot to go through and kind of adjust it until we get the speed that we're wanting to go at. Yeah, it's still choppy. Let's go super dramatic. Yeah. So, and with each of these changes to the state machine, with the interval, the light pattern speed has not changed at all. So, totally great. It's definitely what we're going for as far as like removing all that blocking code. Okay. So from here, what do I want to do? We need to fit in the ultrasonic sensor, but we don't want to just arbitrarily open and close the lid. We want to actually tie that in with the ultrasonic sensor. So I'm gonna take a break and kind of think through it conceptually, and then record another video. So, but I mean, step in the right direction.